Hello, everybody. Here we are, 2.5. I don't think I did fill in the blanks for this because I made some examples for you to write down. So make sure you're following along as we go. This is our last part of chapter 2. So this is the second part of exponent laws, and we're going to refer to section 2.5. Let me zoom in a little. So the exponent law for power of a power. When an exponent has an exponent of its own, we multiply them. So a to the power of m, bracket to the power of n, equals a to the power of m times n. So I will show you an example here. Here's why this is true. If we look at this, it's the same as this is our base now, essentially. Whoa, there we go, to the power of 4. So we could rewrite this if we wanted, as 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2. And if you recall, if you have something same base being multiplied by each other, you can just add up these exponents. And so you get 3 to the power of 2 plus 2 plus 2 plus 2, power of 8, which is the same as if we had from the beginning just multiplied 4 by 2, we would have got 3 to the power of 8. Okay. So let's look at the next one. This is the exponent law for a power of a product. Remember, a product is when two things are being multiplied by each other. So this is an answer. What word is that? Answer of a multiplication problem. So when two different bases are being multiplied together and share the same exponent, we distribute that exponent to each of the bases. So if you have a times b to the power of m, we can rewrite this as a to the power of m times b to the power of m. So what we have right here, if I showed this, expanded this out, it would be the same as 3 times 4 times 3 times 4. And you could rewrite this as 3 times, here's another 3 times 4 times 4, or 3 to the power of 2 times 4 to the power of 2, which would be the same if we had just distributed this exponent into each of the numbers inside the brackets. So if you had done from the beginning 3 to the power of 2 times 4 to the power of 2. And the reason that I drew this really complicated question, I got this from the Math 12 curriculum. I think it could be tempting to ask, why are we learning this right here? Because we can also solve it with BEDMAS. We can also, just do, 3 times 4 is 12 to the power of 2, and that would come out as 144. This, for example, 9 times 16 would be 144. Why can't we just do this? We already know how to do that. What's the point of this distribution, this law for the power of products? But all of these things become really important when you're trying to solve questions like this. When you get into grade 12 math, even in grade 10 and grade 11, you need to know these laws when you start to deal with things that aren't numbers. So it's really good to practice these things, even though maybe at the moment it's not exactly clear, why this is better than just doing BEDMAS like we usually do. It becomes much more important later when we're doing more complicated problems. Okay, not to freak you out, there's going to be at some point where you know how to do this. Okay. The last law we're going to look at today is the exponent law for a power of quotients. So when two different bases are being divided together and share the same exponent, we distribute that exponent to each of the bases. So if you have in brackets a over b to the power of n, it's the same as a to the power of n over b to the power of n. So I'll show you what this looks like. If we expanded this out, we would have 5 over 6 times 5 over 6 times 5 over 6, which is the same as 5 times 5 times 5 over 6 times 6 times 6, which is the same as 5 to the power of 3, 1, 2, 3, over 6 to the power of 3, 1, 2, 3. So we could have just distributed this 3 to each of them from the beginning. So that proves why this works. So let's do a couple of examples. Let's remember the law for the power of products. So let's distribute into each of these. We get 3 to the power of 4 times 2 to the power of 4. Let's use my calculator. I need to get a better calculator that does more complicated stuff. I don't know. Can I do this? 3 to the power of, no, that's squared. Okay, well, I'll do 3 times 3 times 3 times 3 equals 81 times 2 times 2 times 2 times 2 equals 16. And let's go 81 times 16 equals 1296. Let's do the next one. So again, we can distribute this 2 inside the brackets, and we get negative 4 to the power of 2 times 3 to the power of 2. Negative 4 to the power of 2 is negative 4 times negative 4, so that's 16 times 3 is 9, and that equals 144. Let's look at the next one. Remember, this is the exponent law for a power of a power. We get to times these two right here. So we get 3 to the power of 4 times 2. We get 3 to the power of 8. And that equals, we're going to have to do it. 8 times 3 times 3 times 3 times 3 times 3 times 3 times, what am I at? 1, 2, 3, 4, 5, 6, 7, 8, 6, 5, 6, 1. And our next one, again, we can multiply these. I know we have our 0 exponent law, which means that anything to the power of 0 is 1. But let's not be confused. Remember, anything times 0 is 0. So we end up with 5 to the power of 0, which equals 1. So that was 3 times 0 is 0. Now 5 to the power of 0 is 1. If you wanted to solve it our old way, remember you could just do 5 to the power of 0 is 1, and 1 to the power of 3 does equal 1 as well. Let's do the last two. Let's distribute our power inside first. Okay. So we can go 5 to the power of 4 times 2 is 8, divided by 5 to the power of 2 times 2, so 5 to the power of 4. Now remember our law that if we have the same base being divided, we can subtract the exponents. So we get 5 to the power of 8 subtract 4, which is the same as 5 to the power of 4. We can solve that. 5 times 5 times 5 times 5 equals 625. And our last one, let's deal with these brackets first. Let's distribute our exponent inside to each of them. So I'm going to rewrite this negative 1, 3, all to the power of 4, subtract 2, let me just do big bracket, negative 1 to the power of 2 times 4 is 8, divided by negative 1 to the power of 2 times 3, which is 6. Then we can go, we got the same base here, -1 and -1, and it's being divided, so we can minus our exponents. Let me rewrite this. -1 to the power of 3, all to the power of 4, subtract. 8 minus 6 is going to be, let's do our big bracket, -1 to the power of 2. Now let's distribute this one. And I think we can get rid of our square brackets at this point. So let's go -1 to the power of 12, subtract -1 to the power of 2. And let's go. I'm going to use my calculator off screen here so I don't have to do a million ones to the power of 12. So we get 1, subtract, and -1 to the power of 2, I think, is also just 1. 1, that equals 0. Okay, I will give you the textbook questions. Thank you so much.